This is homework help for the heartbeat worksheet, which is Waves Basics Calculations. The equations that you're going to want to know are our basic velocity equals distance over time, wave speed equals frequency times wavelength, frequency equals 1 over the period, and period equals 1 over frequency. It would probably also be helpful to review yourself on what the definitions for frequency, period, and wavelength are before you start these. Okay, let's take a look at number 1. Nurse counts 76 heartbeats in 1 minute. What are the period and frequency of the heart's oscillations? So in this problem, a heartbeat is going to equal an oscillation. If you recall, the definition for frequency is oscillations per second. This problem gives us heartbeats or oscillations per minute. So the first thing we need to do is a conversion. So we have 76 beats or oscillations in 1 minute, and we need to know in 1 second. So in 1 minute, I have 60 seconds. I'm going to go ahead and multiply across and divide 76 by 60, and that gives me 1.27 beats per second, which is the same thing as 1.27 hertz. And that is my answer for frequency. To find the period, we're going to use our period equation, which is 1 over frequency. So 1 over 1.27 gives us a period equal to 0.79 seconds. So that means it takes 0.79 seconds for 1 heartbeat to occur, and there are 1 1/3 heartbeats per second. Another problem we can look at is number 3. It wants us to calculate the speed of waves in a puddle that are 0.15 meters apart and are made by tapping the water surface twice each second. So if we're thinking about our givens, wavelength is the distance from one wave to the next, and so in this case that will be our 0.15 meters. Frequency is the number of waves per second, so that's going to be the twice each second. So with those two givens, the equation that would make the most sense to use would be velocity equals frequency times wavelength. Sometimes there's some confusion about what's the difference between a distance and a wavelength, and a time and a period. So let's look at number 9 for that. This problem tells us that water waves in a lake travel 4.4 meters in 1.8 seconds, and the period of oscillation is 1.2 seconds. So we know that this is going to be our capital T, 1.2 seconds. So what do we do with the 1.8 seconds? Well, that is a time, but it's not specifically the time for a wave or oscillation. So we're just going to symbolize it with a lowercase t. And then it tells you how far the waves travel, but it doesn't tell you the distance of a single wave. So that 4.4 meters is a distance, not a wavelength. So for letter A, what is the speed of the water waves? With the information we have, it would make the most sense to use V equals D over T, because I don't know the wavelength and I don't know the frequency. I don't want to use the other velocity equation. Once I know the velocity, though, for letter B, I can use the second equation, velocity equals frequency times wavelength, to determine wavelength. I am also going to need to do a quick little frequency formula since it gave me period and not frequency. On the back, I want to take a look at number 11 because it's got a conversion that you might not be familiar with. So if you look, you see AM radio signals are at 550 kilohertz. So for converting from kilohertz to hertz, it's not too bad. If you just take a look at your old formula sheet, you'll see that by the kilo line in the exponent in the factors column, you see kilo is times 10 to the third. So 550 kilohertz can be converted by doing 550 times 10 to the third hertz. You don't have to do any kind of fancy conversion, just tack on what you see in the exponent column to the original number. When you do that, do not change the decimal in any way. So another example would be on letter B, 1600 kilohertz would be equal to 1600 times 10 to the third hertz. Two more to look at. Number 14 is a problem about an echo. So I'm not going to give you too many hints here, just a quick little picture. Here's our ship. It's going to send out a sonar signal, and then that's going to come back up. So remember, when you've got sonar or an echo, the sound has to go there and back. So this 1.80 seconds time is a time for there and back. So when they ask for how deep is the ocean beneath the ship, you need to cut your time in half in order to find that, because you don't want time there and back, you just want time there. And then the last problem I want to take a look at is number 15. Letter A tells you to draw the wave. So if we just draw a simple sine wave, give ourselves a little equilibrium line here. The problem says the time needed for a water wave to change from equilibrium level to the crest is 0.18 seconds. So equilibrium level is right here, crest is right here. So think about what that means for the fraction of the wavelength, and then use that to calculate period and frequency. Hope that helps. Reach out as always if you've got questions.